Hello, math students. Welcome back to Module 11, Geometry, and this is Lesson 8 called Area. Our goal for today we will find the area of polygons on a coordinate plane by building rectangles and triangles. So we're going to use our information that we know about rectangles and triangles, and we're going to take that original shape and break them into rectangles and triangles to figure out the area. Wow, that was a lot. Okay, the question that I want you to be thinking about during this lesson is, what is the connection between the area of a triangle and the area of a rectangle? All right, so things to remember. There are some formulas for finding the area of different kinds of polygons that I really need you guys to memorize, okay? So let's go over them. When you are finding the area, so capital A on the left-hand side of the equal sign means you're always finding area. So the area of a parallelogram means base times height, okay? When you're finding the area of a rectangle, you do base times height. We also have many times said that it is area equals length times width. Kiddos, base times height and length times width, as long as it's a lowercase b, means the exact same thing. So area for parallelogram and rectangles can be length times width or base times height, depending on what you call it, okay? Area of a triangle equals, find the base times the height, and then cut it in half. So half the base times the height, base times height, cut it in half the length times the width, however you want to say it. So this one could also be half of length times width. Okay, so again, same thing. All right, triangle we just did half the base times height, half the length times width. Okay, area of a trapezoid. This one's new, and so I don't remember if we actually talked about this or not, so we're going to go over it one more time. Area of a trapezoid is very fun, but you have to pay attention to what you're doing. So you take base 1 plus base 2, and then you times it by 1/2 or divide by 2. And then when you're done doing that, you multiply it by the height. So some of you are going, oh my gosh, I don't know what she's talking about. So here's a trapezoid, yeah? This is what you guys are used to when I say trapezoid. Trapezoids actually come in many different looks based on the one rule that a trapezoid has one set of parallel lines. Okay, one set of parallel lines. So base 1, it really doesn't matter as long as you have 2 of them. So we're going to name this base 1. So what we're talking about is the length of this right here. So this is considered base 1. Well, if that's base 1, then this right here is going to be considered base 2. Okay, because a trapezoid has 2 bases. It has a top and a bottom. Okay, and this could be base 2 and this could be base 1. It really doesn't matter as long as you can identify your base 1 and your base 2. So if you look at this, it says base 1 plus base 2. So you're going to take the length of this guy plus the length of this guy. Then you're going to cut it in half or divide by 2, multiply it by 1/2 or divide by 2. And then when you get done, you're going to multiply it by the height. This right here is the height because it tells you how tall the trapezoid is. So that's the height, okay? So you're going to say base 1 plus base 2 divided by 2 times the height, okay? Base 1 plus base 2 divided by 2 or multiply by 1/2 times the height, okay? That's how you find the area of a trapezoid, okay? Area of a circle, we already covered a little bit earlier in this module. You're going to take pi times radius squared, okay? Another one that helps a lot of kids when we say it is the area of a circle is pi times the radius times the radius. That's what you're doing, okay? Pi times the radius times the radius. Okay, so those are really important formulas. If you can't commit them to your memory, make sure you write it down and remember what page it's on because you're going to need it. All right, so we're going to use those to help us try these area problems. So it says, try this, find the area of the shaded parts. So the shaded parts didn't show up. Basically, you want to have the area of all of these different polygons. And so if we're taking a look at this, this is kind of interesting because we know that this is a triangle, we know that this is a trapezoid, and we know that this is a parallelogram, okay? So find the area of these parts. So go up here to our handy dandy formula helper, and it says half the base times the height. Well, what you have to decide then to do this is you have to figure out what is the distance from here to here, and that would be your base or your length. And then you have to find your distance from here to here, and that would be your height, and then cut it in half. Okay, so the way we find our length is you're on a coordinate plane, so you have to count. So 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units. That line is 7 units long, okay? And then you do the same thing for the other side of the triangle, 1 unit, 2 unit, 3 unit, 4 units. So this one is 4 units. And then if we remember, triangles are length times width divided by 2. So we're going to take 7 times 4. 7 times 4 equals 28. And now I'm going to divide it by 2. And when I do that, I get 14. And so the area of this triangle is 14 units squared, because area always is squared. Area is always squared. What is area? Squared. What is area? Squared. What is area? Squared. What is area? Squared. So your answer has to be units squared. Okay? So that wasn't bad, right? Okay, trapezoid. You have two options. You can try it with this one, the formula, or I want to show you something, and I'm actually not going to do this one with you because I'm going to make you do it by yourself. But what happens if we extended an invisible line there? What shape do you see? A triangle. Well, we just did a triangle. Okay, what if I extended this invisible line here? What shape do you see? Oh, a triangle. We just did a triangle. And then what shape do you see right here? A rectangle. And we know how to find the area. So, kiddos, here's what I am requiring of you, because I don't have any other practice problems for you, and I need you to try a couple by yourself. You have to do this problem two ways. You're going to use the formula to practice it. Okay, but then to check your answer to make sure you got it right, you're also going to go back and find the area of this triangle, this rectangle, add them all together, and they should be exactly the same answer. Okay, so you're going to try that for me. Okay, last one that you're going to try without me, and we'll talk about it in class tomorrow. This is a parallelogram, and if you go back up here to the top, the parallelogram means base times height. This is where it gets very, very confusing if you're not careful. In a parallelogram, this slanted guy is not the height. Did you hear me? In a parallelogram, the slanted guy is not the height. The height is the distance from the top of the parallelogram straight down to the bottom. Okay, so what your job is you have to look at your coordinate plane and get an eye of where you think it is. And so what we have to do is we have to try to figure out, and I'm sorry, for some reason these lines didn't come through, so I'm going to go ahead and draw them for you so that you don't have to make it up as you go. And let's say it looks about here for me, I think. Oh gosh, sorry, my marker's running out. So I would say that's in a half. Okay, so if you're counting, it would be 1, 2, 3.5 is the height, right? So you're going to say 3.5 is the height, and then you have to figure out the base, because it's base times height. So you went from, here, let me get a different marker because that one's not working. So you're going to go from here to here, figure out, and then go from here to here to figure out. And then that's how you can figure out that parallelogram, okay? All right, so I want you to figure out the trapezoid and the parallelogram. Remember, area always means squared, so unit squared for your answers. Go back up to the top. Today, we will find the area of polygons on the coordinate plane by building rectangles and triangles, which we just did. The question for the lesson is, what is the connection between the area of a triangle and the area of a rectangle? The connection is that for every area of one rectangle, you have the area of two triangles combined. That's the connection. Two triangles make up one rectangle. Yeah, it's a proven fact, because every rectangle has a right angle in each corner, and if you have a right triangle in all the corners, then you are making a rectangle. So think about that. That's kind of cool. All right, kiddos, that's all I have for you in this lesson. I will talk to you later. Bye!